we're going to go ahead and get started. Hi, everybody. I'm David Simmons. I'm the head of developer advocacy at StarTree. And tonight I'm going to give an introduction to StarTree and to Apache Pinot. And then I'm going to give a demo. And the demo is actually something that I just built last week. So we'll see, and hopefully it goes well. So anyway, that's me. That's my Twitter handle in the bottom right corner, and it'll be there on every single slide, so you won't miss it. Okay. So start off, well, I guess I should ask how many people know about Apache Pinot and real-time analytics? And Barca, maybe you can do a count of raised hands for me so I can get an idea, because I can't see any of that anymore, about how many people know about it.
No hands raised.
Okay, so we're all starting from the beginning. That's great. So real-time analytics is, I mean, this is Gartner's version of it, but it's basically looking at data in real time and analyzing that data in real time to make better business decisions, make better decisions, applying logic to it and make better decisions, make them more quickly, basically in real time. And this is something that analytics has been sort of moving towards for a long time, but we're finally kind of here. You know, back in the old days, we would do sort of batch analytics, right? We'd get all the sales data from the last month and we'd run a batch on it, and then we get our report back and we could look at it and see what we did last month. Well, that's gotten better as we've gotten, you know, better databases. We could sort of run that on the last day or the last couple of hours, but still that was a lag behind what's going on right now. And real-time analytics really lets you go and make those kinds of reports and dashboards and get those insights on what's happening right this second, and literally right this second on very fresh data. So what we're talking about is events, and that's really sort of any kind of event that you're capturing, whether it's you know, a sale at a point of sale or an order or whatever it is. And you're going to capture those events and you want to get some insight into what's going on around that event. And then you want to be able to take some action on it, right? So somebody placed an order and I want to be able to see all the orders that are coming in for that particular item. And I want to be able to take action on those in real time so that I don't run out of inventory and I can get those orders processed quickly, right? And if you ever order from Amazon, you probably see things like, you know, your order's being processed, your order is shipping, and now it's shipped, and now it's out for delivery, and all those sorts of things, right? And that's the kind of insight and action that we're looking for in real time. So this is a very scientific graph of the value of data over time, right? And basically what it shows is that as you get sort of closer to immediate, your data is much more valuable, right? As time goes on, that data becomes much less valuable. Now, this is sort of music to my ears. I've been doing IoT for almost 20 years now, and this is sort of the whole idea of IoT, right? Is your data is in real time. You want to see what's going on right now so you can make decisions on what's going on right now. What happened a week ago is not really all that useful, except in sort of in a larger format of what are the larger trends. But in actually taking action and doing something with your data, it's based on what's happening right now. I want to see what's happening right now so I can make a decision right now and have an action right now, right? So all sorts of people are interested in this data. Anybody from analysts to management to, you know, people in the warehouse floor who are fulfilling orders to users, right? If I'm ordering from your company and I can get real-time updates on what's going on, then I feel more engaged with what's going on with my order, right? When I order something from Amazon and it just sits there forever and I don't get a status update, and then suddenly it shows up on my porch, it's great, it was delivered, but I'm kind of more invested when I can see where it is along the process, right? If I can see that, okay, the order's being, there's somebody's getting it ready, it's in shipping, it's been shipped. And I especially like it when I get the updates of, it's 10 stops away, right? And it's 9 stops away and I can actually watch the truck. That's kind of what real-time analytics and real-time data is really good at. It really just does engage people a lot more. So this is sort of the quadrant of what is real-time analytics. And then, so there's the machine-facing stuff, which is really observability. And in that area, we're looking at sort of what's going on in your infrastructure. How are your applications performing? How are all the parts of your infrastructure performing? Internal dashboards, I can have real-time dashboards so management can see exactly how many products are going out the door, how many orders are coming in, how many people are out on the floor of the warehouse picking products, how many drivers are out and where they are in their driving route. You can use all of that data as well for fraud detection, right? If you can monitor these transactions in real time, you have a better chance of catching fraud in real time rather than a week later where you have to go and refund the customer and you're out the money that the fraudster took from you, right? And again, external is an order tracking service, something that the end user, the customer, can see. And we'll see this in things like Uber Eats and other applications like that, where that real-time data is not just for the business to look at, but it's also for the customer to see in real time so they can keep up with where their order is. Some examples, LinkedIn. Actually, it turns out LinkedIn is where Apache Pinot was invented. LinkedIn needed a way to be able to present all this data to users. When you go and see who's used your profile, right? That's all real-time data. And they are processing a lot of it. They have 700 million users on LinkedIn. They're doing about 10,000 queries per second. And their query speed is less than 100 milliseconds, right? And the data that they're looking at is seconds old. So they are ingesting a huge amount of data in real time, and they are querying it in real time, less than 100 milliseconds, and presenting it to you, the user, in real time. Now, as just a sort of a standard LinkedIn user, I don't see as much of this as you would if you're a business and you're tracking your ad campaigns and your job postings and things like that. When you get to those areas of LinkedIn is when their real-time analytics is really quite prominent, because you can see the things changing in real time. Typically, the number of profile views is not, you're not in the hundreds of thousands or thousands, so you're not seeing that much data come in. So again, here's kind of the things that are driven by real-time analytics, right? The views of your posts, how many people have viewed your profile, all these sorts of things are being ingested in real time, being presented to you as a user in real time. And again, this is sort of the behind the scenes kinds of dashboards that you see as a recruiter or something like that, when you've got job posts and you can see, how many people are out there, how many people are looking at your job post, how many people are applying, where they're from, all this kind of data, right? This is one of the examples that we use all the time is Uber Eats. So when you go to Uber Eats and you want to order something, you want to know which hamburger joint close by has the lowest wait time, right? And what those wait times are. So it doesn't do you a whole lot of good as a consumer if the data is a day old, right? Well, yesterday at this time, the wait time was 10 minutes. Well, that's great for yesterday, but for today, the wait time may be 45 minutes, and I want to know that before I place my order. So a lot of these real-time analytics at Uber Eats are presented to you, the user, in real time so that you can make decisions. They also present these dashboards to their affiliate restaurants so that they can see all this stuff that's going on in real time, right? How much they've sold in the last 12 weeks, how much they've sold in the last 12 hours, how many missed orders, all that kind of stuff, right? Uber Eats is has about 500,000 users. They're only doing in the hundreds of queries per second. Again, less than 100 milliseconds of query time. And their data is sort of seconds to minutes old. So when you go to Uber Eats to order something and you look at what the wait time is, that's really been updated in the last sort of couple of minutes, right? It's very fresh data. It's very accurate data so that you know that if it says that the wait time's 10 minutes, that's going to be pretty close to reality because it's only a few minutes old. It's pretty much real time. Stripe uses Pinot for real-time analytics for financial data and reporting. It's great for finding bugs, right? If your software is having something go on a periodic basis, it's a good way to watch that and watch for those things to happen and see them in real time so that you can go and look at the system in real time and find out what's causing it, right? So again, for Stripe, they want very, very high precision and accuracy, right? Their aggregations of their data have to be exact. This is financial data, right? And they have lots of very small transactions. Sorry, my desk is beeping at me. I don't know why. The rounding errors in financial transactions can actually add up quite quickly. So they want to be really on top of that. They want to have very, very fresh and accurate data for this, right? And they want to see it all the way down to the transaction level. Very high granularity, right? So some properties of real-time analytics systems one is speed of ingestion. You're most likely for these systems, you're ingesting huge amounts of data, massive amounts of data, really. And so you have to be able to ingest that data into the system at speed, at line speed, at high volumes, right? We're talking, some of the Pinot clusters are up in the petabytes of data at this point, right? So they're ingesting enormous volumes of data in real time, all the time, 24 hours a day. Next thing is your speed of queries, right? So your speed of ingestion is going to give you the freshness of your data, right? How fresh is my data? It's coming in very quickly. There's lots of it. It's very fresh. Speed of queries gives me the freshness of the data to view. So I really want my queries to be very quick. Human interactions, anything over about 500 milliseconds feels slow. Anything under about 250 milliseconds feels very fast to us. Anything under 100 milliseconds is basically instantaneous, right? So the speed of those queries is really important. If I go to look up an order and I put in my order number and it takes 5 minutes to return data, I'm going to be bored. I'm going to be upset. I'm going to go away, right? If I can get that answer in, a second or two, given all the laws of physics in between me and the system, then I'm going to be much happier about that. And then the third thing is scalability, right? It's one thing if I'm only ingesting a small amount of data and I'm making a few queries and I can get those queries done very quickly. But when I'm ingesting, terabytes of data and I'm doing massive amounts of queries, like 10,000 queries per second, I really need to have scalability built in because it's not the kind of thing that you're going to be able to do with just your standard sort of off-the-shelf MySQL database. You're not going to be able to scale that to those sizes and get that kind of ingestion speed and query speed out of it. It's just not going to happen. So if you're going to build one of these real-time analytic systems, you're going to need real-time ingestion of high-dimensional data at high velocity, right? Lots of data, lots of different kinds of data from lots of different sources. And you want that highly available. So Kafka is a really good way to do that. Kafka is very scalable as well. It takes lots of data. It handles that sort of high-dimensional, high-velocity data very well, right? And then on the database side, you really want, within a few seconds of freshness, thousands to tens of thousands of queries per second and millisecond latency on your data. These are scalability factors that sort of are increase the complexity geometrically, right? Because you're not just dealing with, well, I'm ingesting a little bit of data. Okay, I'm ingesting a huge amount of data. Great. But it's also highly dimensional data. So there's a whole bunch of aspects to it. Oh, and there's a ton of it coming in from a whole bunch of different sources, right? So I've got all those things. And then I've also got to look at how fresh is my data, what are my query speeds, and how many queries can I support? So the dimensionality of all this gets sort of quite large quite quickly. So a bunch of sources that a lot of folks use with Pinot are things like Apache Spark, Hadoop, Kafka is a big one. There's a whole bunch. You can also ingest data from standard SQL databases, right? And we bring all that into Apache Pinot, which has a whole bunch of different indexes and divides the data up in columns and makes it really, really easy to query. It performs really high, well, they're calling it performant aggregations, but it's performing aggregations very quickly. And it's doing optimization of the segments so that you can scale this, right? Basically, what you get is you have your data ingestion, you have your Kafka, and it sends data to the Pinot controller, and we use Zookeeper to segment the data, right? So that way we can segment the data across a bunch of Pinot servers. That makes it easier to ensure that your data is always available, right? So I'm spreading the data segments across the Pinot servers via Zookeeper, so that if, say, server 1 goes down, that would take segments 1 and 3, right? But I can still get segment 1 from server 4, and I can still get segment 3 from server 3. So I didn't lose anything, right? I'm still able to query that data even though one of my servers is down. The other thing is that I can bring on more servers as the load increases, and Zookeeper will start segmenting across all of those servers. And so I'm able to scale the data ingestion and the query across all of those, right? And then we have a Pinot broker. And the Pinot broker is where you submit your query to, right? So I want to select everything from this, where country. I have a SQL statement. I submit that to the Pinot broker, and it goes out and queries the various Pinot servers to get answers for that, right? Okay, it's demo time. So here is so I did all of this in StarTree Cloud because I didn't want to sort of spin up a bunch of Docker containers and all this kind of stuff on my local machine. So I'm doing this actually all in StarTree Cloud. And we have a portal where, and I really hope it's not timed me out. Nope. So I have an organization for myself, and it's my playground. and I can see that some information about it. And here are the services that I have, right? So I have my applications, I have data manager, and I have Grafana. We're going to go look at data manager first. This is where I set up how I'm going to bring my data in, right? So you'll see I've got some data sets here already. I've got one for employees, I've got one for sensor data, and one for badge scans. What I'm going to be showing you is basically I have this, let's see if I can get it high enough that you can see it. I have this badge scanner. It scans NFC cards, and I'm scanning badge data and putting it into Pinot in real time. So we can go and look at how that data is structured. So here's the table config, and here's the schema for that data, and there's not much. It's there's really not much to it. We can go and look, we can query that data and see what we have in the way of badges, right? To back up a little bit, I had to have a way to read this badge data off of this scanner and get it into Pinot. So what I did was I wrote this little program in Go, which really doesn't do much. It finds a badge reader, it waits until there's a card present, then it connects to the card, reads from it, and sends it to Kafka. And then it waits until the card is gone so that it can go back and start waiting again. And you can see down here in the console, it's been spitting out all this stuff. Here's the badge number and the scan time. So I have a lot of these little NFC badges. I have them in round ones and little square ones. And if I put this, there you go. You see it produced an event, and here's the badge number, and here's the scan time. And I can take it off. Now, if we go back to our Pinot broker, I believe that's the one that we just scanned, isn't it? 168.819. Nope. Are they not coming in? Let's try that again. There it is. There's the most recent one. Not sure why the first one didn't go through. So I'm now scanning those in real time into my system.
David, it's in there. I see that 819. It's like the third to last. It's just not in order.
Oh,
So we just didn't notice it, I think.
oh. I'm terrible with writing SQL in real time, so you'll have to watch me be terrible.
Yeah, I think that 819 is the top bottom one, right?
Yep.
And if you run the query again, there's the 38 and then 819.
Yep. And the 19, right?
Perfect.
Great. All right. So my terrible SQL skills aside, that's what we get, right? So that's basically ingesting in real time. Now, I'll show you another thing that I've got going on here, and I'll give you a hint as to where all this is going. So if you're reading the D-Zone blog post, there's going to be another one tomorrow, and then there'll probably be another one by the end of the week to sort of try to pull all this together. So what you'll see, I have these tables in here, and I have this simple dimensional table here that is just an employee's name and their badge number. And then I made up some other stuff about them, right? Doesn't matter. And then I've got this, I built this contraption here, which is an environmental sensor. So it reads CO2 and temperature and humidity in real time. And if we go and look at our sensor data, oh, I know. See, what's it called? Or did I fail to start the sensor? Yeah, because that's not real fresh data. So hold on. Yeah, that seems to be hung. So we'll restart it here. Are we seeing stuff come through here? No. Again, I wrote there we go. Now it's starting to run. So I wrote almost the exact same Go program. It's really hard to get things off of an Arduino straight to Kafka. There's no real way to do that. And so I'm sending it to an MQTT broker, and now I'm reading from that and sending it off to Kafka. The other thing that's hard to do on these tiny little devices is get an accurate conception of time. They don't really do time very well. So the other thing I'm adding here is I'm adding the timestamp here rather than on the device. So now if we go here, here we go, brand new readings. Now this one sends data quite a bit. It's reading basically once a second, right? And it's sending basically a 4-dimensional data structure once a second. So one of these is not really a big deal to have going, but let's say I'm running a chemical plant and I have one of these sensors or 10 of these sensors in every enclosed space in the chemical plant, right? Suddenly the amount of data is going to be a lot higher, right? Now the sort of the secret that you're going to get that most people won't get until they get all 3 blog posts is the idea is that I have badge scans in real time, I have sensor data in real time, and I have employees. So I can put one of these badge scanners outside of, say, an enclosed space that has a sensor in it. And when somebody badges in, I know now who's in that room. And I know what the CO2 level is in that room. I can have another badge reader for when they badge out of that room. So if the CO2 level or whatever gas level gets dangerously high, in real time, I know that it's getting dangerously high and I know who's in the room and I know who they are. I know their badge number and I know who they are, right? So that if it gets to a critical stage, I know that I have to send, how many rescuers do I have to send there to get those people out, right? Well, there's 10 people in the room. I can't just send one guy, right? There's one person in the room, so I can send, a team of 2 to get that person out. So that's kind of the system that I'm in the process of building. I only started writing the software for this on Thursday of last week. So it's coming along quite quickly. And really all I need to do now is figure out the kinds of table joins that I need to do in order to monitor, set an alert for when that CO2 level gets to a certain level, and then go look up the latest badge scans, right? And see how many are there. Does that make sense? That's kind of where I'm going with all this. And this is not, I guess, a traditional use of real-time analytics. It's not something like, tracking orders and those sorts of things. But it could be a critical use of real-time analytics in that you really need to know immediately what those sensor values are and who's in the room, right? Because if, say, you're running a chemical plant and you're not just looking at CO2, but you're looking at other dangerous gases, you really need to be able to alert the people in the room and alert, first responders if something goes wrong. And you need to be able to do that as quickly as possible and in real time, right? Because, looking at the data from yesterday and saying, yeah, well, that really went bad yesterday. Guess we got to go retrieve those, and they're now bodies instead of people. So that's kind of where I was going. I was considering this afternoon rewriting part of it to be to do sort of inventory, which is something else you could do with this. Is every time somebody checks out, they scan a product, and now I can go. I know that product was just scanned. And so I can go look up the price. I can look up the inventory. I can do all kinds of stuff to do real-time reporting on that product based on every time something's scanned, right? And again, that's small scale if I'm just doing, one thing. But let's say I have 1,000 stores across the country. I want to be able to track all that inventory in real time, track those sales in real time, give management insight into what's going on in each store in real time. So this is really it, right? Any user-facing real-time analytics use case. And I just gave you a couple of different ones from wildly different areas, right? I'm producing a ton of events. I'm pointing those events to Kafka. I'm pointing Pinot at Kafka and ingesting those, and then I'm querying them. And I can set up dashboards and things on the front of that so that I can see those things in real time so that the queries are running all the time. You just saw me do some fairly simple queries just using the query console. So it wasn't all that exciting. And here's our NASCAR slide of all the people that are currently using Apache Pinot. There are a ton of them: LinkedIn, Uber, Target, Walmart, Hyundai. There's a lot of use cases for this. There are almost as many use cases as you can think up, and then more. There are tons that I would never think of. It's like, oh yeah, when I hear it, it's like, that makes sense. That's actually a great thing. We have a really great community. So if you want to join our community, please do. All right, here's the takeaways. You can create applications that give users actionable insights, right? And not just users, but management and everybody else can have access to basically the same data. It really democratizes your data. because you can make that data available not just to the people inside your company who are watching the inventory and things, but you can also make that same data available to your customers so that they can see, where things stand with their order, where things stand with their products. The basic properties of all of these systems are very fresh data, very fast querying at large scale, right? Those are really the three key parts of it. And Kafka and Pinot are really a good match for that. You see that I've been using Kafka. I'm sending all my messages to Kafka, and Pinot is ingesting them from Kafka. So I could be sending a lot more data without even the system breaking a sweat. Right now, I'm not doing very much, and it's basically putting no load on the system. Okay. So there's a QR code for you. These are all the ways to contact me. My email, my Mastodon, my Twitter, LinkedIn, and my personal website, davidgs.com. If you want to join, now I only had room for one QR code here, so I didn't overwhelm you with them. But if you want to join our Slack community, you can go to dev.startree.ai/Slack, and you'll be sent to the inviter to get yourself invited to our Slack community. And with that, we're done. Well, I'm really glad that you were all here. And I hope you got something out of it.